Hello and welcome to this lecture. In this lecture, we'll learn about shallow copy and our deep copy using Python. So it is a technique to copy an object in the Python. So in Python, we use this equal operator, that is our equal operator that we use in the mathematics to create a copy of an object. And you may think that this creates a new object. It doesn't. It only creates the new variable that shares the reference of our original object. So let's take the example where we create a list, name old list, and pass a object reference to the new list using this equal operator. So let's go over here and let me just create my new list. As I already showed, I'll just create the two list over here. So let me say new list, so it should be old list, not a new list. So let me say first old list, which is our old list, and this contains set of elements, so this should be inside this list, and I want to just copy this list to the new list. So first of all, I'll just say that is new list, and in this new list we'll just make use of this word list and we'll just assign this word list in this new list. And here I'll make some elements. Let me say 1 2 3, and let me just close this list, which is basically a nested list over here, and I'll just say 4 5 6, and the last one would be, let me say 7 8 A. So 7 8, and we'll just put A here, which is our string, and let me just close this one. So now it's time to just work around with this list. So in order to make reference to the element to the list, you know how to get the element, that is using this square bracket, and just give the position over here. Since it is a nested list, we have to make use of these two square brackets. So I'll just say 2 over here and 2 over here. So if you wonder what this 2 and 2 looks like, that means you are just going from this 0 and you are just referencing this 1 and you are referencing to this 2. So you are just referencing to this list, and inside this list you are referencing to this A basically. So this is for 0, and this is for 1th position, and this is for 2 position. That means you are referencing to A, and we'll just assign 9 to this A. So now let's print this old list, which is our old list over here, and let me just format this down, and let me just give here colon, and let me say old list, and we'll just print this old list here. And next is we'll just say id of this old list. So I'll just say id of old list, which is here, and we'll just make use of id method in order to get that id, and it should be all in lowercase id, and we'll just pass here old list. So we have now created this next print method. So let me just copy this one and paste after this code. So instead of old list, it should be now new list, and we'll just call this new list over here. It should be new list, and id should be of new list. Let me just change this old to new, and we are good to go here. So let me just save this one and let me just run this code. Then you could see we have here change from this 0, that is in this case we have A not 0, we have A element that was basically changed to 9 here. So we have an id of this old list is same as the id of this new list. So you can clearly see that this output, both variables, that is old list variables and new list, shares the same id, that is this value over here. So if you want to modify any value in the new list or old list, the change is visible to the both. So if I just change here from 9 to, let me say give O, and if I just save this one and print this again, then you could see the change is within this same, basically the O and O has been changed to both of these. That means the id is same here. That means if you want to modify any value in the new list, or if you want to just make change in the new list but not with the help of this old list, so old list should be independent of new list. But in the case of this equal operator, or assigning with this equal operator, you simply copy this object, which is basically old list, to the new list, and if you want to change any of the lists, that will be visible to both of the list. So you could clearly see in this console that we have the same id. That means change to any of this list will remain dependent to another list too. But sometimes you may want to have this original value unchanged, basically of this old list, and only modify the new values, or vice versa. In Python, these are done using the two method of copies, that is shallow copy and deep copy. We'll just take each of these example in this lecture. So let's get started. So first of all, we'll just start with this shallow shallow copy. So first of all, let me just say we have the copy module. So in order to support the shallow copy, or in order to support the deep copy, we have something that is importing the module. So first of all, let me just import that module. So I'll just say import copy. So copy is the module that contains some method in order to support the shallow copy and a deep copy. So shallow copy creates a new object which stores the reference of the original element, which is basic functionality of a copy method. So a shallow copy does not create a copy of a nested object. Instead, it just copies the reference of a nested object. So just remember that it is really important. A shallow copy does not create a copy of a nested object. That means it won't copy or make a copy of nested object, but it will only copy the reference of the nested object. This means a copy process does not recurse or create copy of a nested object itself. So let me take an example and let me make you clear what I am talking about over here. So old list should be, let me make a old list. So let me just go back that with the code, and let me just make use of this copy, which is basically using this same code that we written, and we'll make use of this old list. So let me say this is our old list, and let's go here, and we have to import copy that contains the method to support the shallow copy and deep copy. So first of all, we'll just say new list here. So now the new list should be called is the copy module. So we'll just make use of this copy module to call this copy method. So copy method is only for this shallow copy, but if you put something like deep copy, then it is for the deep copies. So if you just put copy over here, that is for the shallow copy. So I'll just say old list should be copied to this new list. So it's time to print this list. So I'll just go over here and I'll just say old list, and let me just give space over here, and I'll just say old list. Now let me just copy this one and let me just paste it over here, and it should be over here. Now here we'll just make a new list to be printed, and let me just format this old with new list. So if I just save this down and print it again, then you could see the same list over here, which is basic functionality of this copy. So copy is for shallow copy, so we make use of this for the shallow copy. So this is the method to support the shallow copy using this copy module. In this program, we created a nested list, which is basically to support the shallow copy using this copy method. This means it will create a new and independent object with the same content. To verify it, we'll just print the new and old list over here, which is done just before. Let me just save this down and show you, and you could see old list and a new list, which is basically a different object. And to confirm that, we can also make a addition to the new nested object to the original and check it. So let me add some more code over here in order to append some list to this old list. So I'll just say old list, and I'll make use of this append in order to append a new list that could be 444. Let me just make use of this, and let me save this down and run it again. Then you could see that is 444 has been added to the old list, but the new list is remain unchanged. That means we have preserved here the new list, because the change in the new list is not going to happen. Only change in the old list is going to happen with this copy.copy, which is basic functionality of our shallow copy. So the new list contains a reference to the original nested object stored in the old list. Then we add the new list, that is this item over here, to the old list. This new subset was not copied in this new list, and that means this new list remain independent of the old list. However, when you change any nested object in the old list, the changes might appear in the new list. So let me take the example. If you make any changes to this old list over here, so instead of just appending, let me make change to this old list. So I'll just say old list, and let me just make 1 and 1, that is to reference this attribute over here, which is 5. So let me just change this 5 to something, let me say AA. So if I just save this down, and you could see the changes might appear in the both of them. So you could see A and A is replaced in both of these lists with this A and A in the position of 5. So this is valid because this is to just add new nested object using this shallow copy. But instead, what you need to do here is we just make use of this append, that is appending a new list. And in this case you might see the new object or the new list is seen to be appeared in the old list only. So you could conclude that while getting to add the new list to our old list, it remains independent because the new list was independent here. While printing, you could see clearly that new list doesn't contain 4 and 4 and 4 element to it. It's a new list, but while we make changes to the element of the old list, that might affect to our new list too. So it is important to know about the shallow copy. It preserves the new list or old list just independent of one another. That means the changes to one might not affect to another, but in the case where we just replace the element of one, might change appear to another list too. So let's talk about the deep copy now. So for the deep copy, I want to make use of same code over here, that is our here, that is old list. So instead of just copy, I'll make a new list. So I'll be making here old list, which is our variable, and we have to import the copy module in order to support the deep copy, same as we have for the shallow copy. So I'll make something that is 1 and 1 and 1, which is basically our first list, 2 2 2, which is second list, and let me say 3, it should be inside this list, 3 3 3, which should be our last list. So we have now old list. Now let's make new list, which would be called from this copy module, and the method that we are really interested is deep copy. So in this deep copy, we'll pass the old list, which is this list over here, and now it's time to print this old list. So I'll just say old over here, and if I just give here old list, that is this list over here, and let me just copy this one, and let me just copy and let me paste over here, then you could see we have to now format it with the new list, and here instead of old, I'll just say new. So if I just save this down and run it, then you could see same, that is the output over here, 1 2 3 and 1 2 3, which is our list, which was same as here if we just put a copy instead of deep copy, which was the same output in the case of our shallow copy. So I'll stick with this deep copy, which is for this deep copy. So next thing what you can see in this is we'll just check if adding a new nested object might affect our list or not. So let me just go over here and add some of the element to our old list. So when I just add something like old list, and let me just make 1 and O, so here I'll just add something that is BB. So if I save this down, so you could reference that we are just referencing this element, which is the first element of the second list in this word list. So if I save this down and run it here, then you could see, so it is because we have just changed over here. So let me just go over here, and it should be down here. So after we just copy, let me see if this change in the word list might affect our copy or not. Let me save this down and show you that it doesn't affect at all. So let me print this down. So the new lists remain independent of this old list. So the changes affect only on the old list, that is B, and B is just printed only in this old list, but the new list over here is remain unaffected. If you see here, this 2 remains unaffected. So in the case of the copy, which is shallow copy, let me just go over here and just put this copy over here, and let me save this down. Then you could see that BB is affected in both of these elements. In the case of the shallow copy, where we added this new nested object in this list, which is basically this nested object, which is BB, to this list. And in the shallow copy case, both lists are affected in the case where we just add a new nested object, but in the case where we just append element, in this case let me just say old list and dot append, which is to append the new list, and I'll just say 444, and in that case the shallow copy doesn't give changes to the new list. So let me save this down and run it. Then you could see 4 and 4 and 4 is added to only the old list, so new list was independent. But in the case where we just made a nested object to be added, so let me just remove this append, and if I save this down and run it again, then you could see the shallow copy was unable to remain independent or to preserve our list among one another, but in the case of a deep copy, so instead of copy I'll just say deep copy. Then you could see this deep copy preserves the independence of these two lists. So BNB is just only printed in this position of the old list, and we have this new copy which is remained preserved. So this is importance of a deep copy and a shallow copy in order to make our old list or any list independent of one another while copying with this assignment operator. So this will be the wrap for this lecture. See you in the next one.